right, welcome to the Chapter 9 practice test. The first thing I'd like to go over is the difference between a number line and a series or sequence. In a number line, all the numbers are there, the real number line. So, real number line. What does that mean? Well, 10 isn't the end, it goes to infinity, right? Forever. Excuse me. Negative 10 is not the end. This direction, it goes all the way to negative infinity. Every single number's there. So if you have your little leprechaun guy here, and he's traveling through all the numbers, he's going to travel smoothly through all the numbers. He's touching every number. So there's infinitely many points. He's going through all the points smoothly. The number line it has infinity to it two ways. It's infinitely to positive and infinitely to negative. But if you just think about, between 0 and 1, there's infinitely many numbers that fit between 0 and 1. In fact, if he was traveling between every number between 0 and 1, he'd keep going, infinitely. It would take him infinity amount of time to go from 0 to 1 even. But there's just, there's just so many numbers. Well, in a sequence, which is just a list of numbers, and then a series is those numbers being added up, you see there's space in between. So there's your first, your second, your third, and you have to jump or hop some way to get to the next one. So the notation for this again was A1 is your first term, A2 is your second term, and then somewhere out there in the future you have AN, which would be the nth term, and then the future one past that would be AN plus 1, which we don't really use that much. This is the one we use a bunch, AN minus 1, that's the previous term. And to get between these terms, if you go smoothly, you'll fall in the water, right? You got to jump between the different terms. So there's two basic ways that we learned about jumping, and that was by adding a number or adding a negative number to make it smaller, or multiplying, or dividing, which is multiplying by a fraction, to get to the next terms. All right, let's see, let's go full screen here. Full screen, and boom. I like the little animation. There we go. Isn't that cute? And yay, he made it across the pond. Okay, back to doing the problems now. Okay, problem number 1. We're supposed to write the recursive formula in 1 and 2. So the first thing you do is you have to tell the whole world the first term. Well, the first term is 41 here. The first term here is 1. So you have to tell the whole world the first term. Then we just do the recursive formula, which would be AN is equal to the first term, which is 5, plus the previous term. For the next one, you have to do multiply to the previous term. So AN is equal to 10 times AN minus 1. So this is the D, right? That got substituted in because the common difference is D. And then this is the R that got substituted in from the formulas. Okay, write the explicit formula for each sequence. Well, what are we doing here every time? We are multiplying by 1.5. How can I tell that? Well, if I start dividing these, if I take this divided by 3, if I take this divided by 2, if I take this divided by 4.5, I get 1.5 every time. So R is 1.5. So the formula is AN is equal to R, no, not R, A1, and then R, and then N minus 1. And then we just plug in the information. AN is equal to first term, which is 2, common ratio 1.5, and then N minus 1. The next one is arithmetic. We're adding the same thing every time, and that formula is AN is equal to the first term plus the common difference times N minus 1. And you can put the D in the front or the D behind. It doesn't make any difference. So an is equal to the first term 7, the common difference. This is going up by 3, and then n minus 1. Now, we can also simplify that by distributing the 3. So that'd be 3n, and then minus 3 from the 7 would be 4, plus 4. All right, so that would be, either answer works, right? Either one of these works. It's just that's the second one is the simplified one. All right, now I asked you to find the 3,113th term so you wouldn't sit there and push the button on your calculator over and over again. So this is screaming explicit, the explicit formula. What's happening each time? We are adding 7 each time, so the common difference is 7. So we have an is equal to first term plus d times n minus 1. So we have a 1,113. The first term is 2. It's sitting right there. There's the first term. The common difference is 7. And then n is 3,113 minus 1. You type that in the calculator, and you get 21,786. That would be the 1,313th term. It's important to understand the simplification of this because I think it helps you to understand what's going on here. You're not adding 3,113 sevens, right? It's one less because if you're standing on the first term and you jump to the second term, you're just adding one 7. So you don't add 3,113 sevens, you do 3,112 sevens. So that n minus 1 is a very important part of the formula. So the answer is 21,786. Next page. Okay, we add and divide. So this would be just 10. And then when you get the answer, it should make sense. So if it's arithmetic, that what's happening each time, well, you subtract 6 and you subtract 6. So that makes sense. So we add 16 and 4 and we divide by 2. It's just a straight average. This is kind of like an average, but it's a multiplication average. We multiply the two numbers together, and then we take the square root. And the answer is 75. The problem is you don't know if you're multiplying by 3 or if you're multiplying by negative 3. So we have to remember to include the plus minus on this. And does that make sense? Well, if I go from here to here, I'm multiplying by 3. And if I go from there to there, I'm multiplying by 3. Or if you wanted to be negative 75, you would multiply by negative 3 two times. Okay, so plus or minus 75 is the answer there. This one here, you're supposed to tell what it is, and I just was like trying to be as creative as possible, come up with something a little more different and interesting that you maybe never seen before. Okay, so we're alternating sevens, so that would be a 7. And then here we see that this is the list of the perfect squares. So there's no real way to, whoops, hey, that would be 36, duh. There's no way to write a real formula for that. So we just know the next two terms. So this would be neither. Okay, write the explicit formula. Because of the r here, we know that it's geometric because that's the common ratio. So we have an is equal to a1 r to the n minus 1. Boom. That's the formula. Picking out the important formula, the appropriate formula is the hardest part to this, isn't it? So we have an is equal to the first term 12, negative 4 to the n minus 1. And that's it. That's it. Just pick the formula out, put the r and the a in there. All right, evaluate. This one here is a finite geometric. I know that it's geometric because it's in the formula, the explicit formula there. That would be r, because I'm multiplying by a half each time. There's two ways to do this problem. You can do the formula, which is probably actually harder than actually just doing the problem and writing the numbers down. So I'm going to make n equal to 1. Maybe this would help you if you thought of it this way: n and then the a. um, an. So if n is 1, n is 2, n is 3, n is 4. So basically, you're just plugging 1, 2, 3, 4 in to this formula right here and getting answers. So when you plug 1 in, 1 minus 1, so I'm plugging 1 there, 1 minus 1 is 0, and anything to the 0 power is 1, so the answer is just 4. Well, since I keep multiplying by half each time, then this would be 2, and this would be 1, and this would be a half. And then you literally add those up. That's what the sum thing does there. You're adding those up. So the answer should be 4 plus 2 plus a 1 plus a half. So you're really adding four numbers together. So it's four numbers and three plus signs. That's all it is. 7.5 or 7.5, whatever you want to call it. Okay, now the formula actually works with this. The formula would probably be the harder way to do it. The formula is Sn is equal to A1 and then 1 minus r to the n power over 1 minus r. So this is for finite. It's a finite geometric series. So we have first term. Well, I know the first term is 1. No. First term is 4 because I just figured that out. And then 1 minus the common ratio, which is a half. And to the power, whoops, I need to put the exponent in there before I do the parentheses. 4, it's 1 to 4, so n is 4. And we have 1 minus r be 1 minus a half. And you type all that into the calculator, and I hope that it's 7.5. Let's prove it. I'll pull the calculator up. We can do it together. So here's a calculator. Yay, virtual calculator. So it's going to be 4. Left parenthesis 1 minus 0.5 to the power of 4. Close the parenthesis. And then I'm not going to type 1 minus 0.5 or 1 minus a half because that's just 0.5 or a half. So divided by 0.5. 7.5. Yay, 7.5. So I could add the four numbers together and get 7.5, or do the little formula and get 4.5. Now, by contrast, this one here is arithmetic. You're not multiplying every time. See, you see this thing right there. See, I just keep multiplying by a half every time. Well, here I'm not multiplying every time. I'm adding every time. See, I'm adding something to 3 every time. I'm adding something to 3 every time. I'm adding something to 3 every time. So this is first term, last term, half the number of terms. Hey, so the first term, I'm going to put 1 in there, and that would give me 5. Now I'm going to put 200 in there, and that would give me the last term. So 2 times 200 is 400 plus 3 would be 403. First term, last term, half the number of terms. There's 200 terms. How do I know that? Because you're going from 1 to 200. So there's 200 terms divided by 2. So this would be 408, and then the first part there's 100. So it's 408 times 100 would be 40,800. All right. Now this caused a big controversy in the first quiz because some people are like, it says sigma notation, what's that? Or summation notation, what's that? You said sigma notation. Well, the book says summation notation, and I called it sigma notation, probably from a previous, maybe a previous life again. Who knows? So I said sigma notation. So they're interchangeable, and you're just writing it out using the sigmas. Okay, so we're going to go 1 to 14. How do I know I'm going from 1 to 14? Because it says you have 14 terms. Okay, now I got to figure out, do I do an explicit formula for arithmetic or for geometric? Well, what's happening each time? So you got to look at it. What's it doing? Oh, I'm adding 6 every time. So since I'm adding every time, I got to do the formula. First term, which is 4, plus the common difference, which is 6 times n minus 1. And that's going to generate all the terms. So then I can simplify it by distributing here, and that would be 6n minus 6 plus 4 would be minus 2. And then summation, let me give it a little more space here. Whoa, I did not want to do that. So I want to grab, no, I don't want to do that. The page is like moving on me. So you're gonna have to hold on here for a second. Click on this, boom, lock, lock into place. Okay, now I can grab it and it won't move. So I'm going to take this, move it down a little bit. Now we can see it better. Okay, so I did 6 times n is 6n. 6 times the negative 1 is negative 6 plus 4 is negative 2. And I'm going from 1 to 6. And that would be, not why did I go 1 to 6? That all threw me off there. How about 1 to 14? There we go, because that's 6 there. I said it again. This would be the simplified answer. The other one works as well. Okay, 3 problems left, and how are we doing for time? We are at 15 minutes. Yay! So, this one here is infinite, and I asked you to sum it up, so I'm not playing tricks here. You can sum it up. The common ratio is sitting right there, because it looks like the explicit formula. The first term is really sitting right there, because it's the explicit formula. First term, common ratio, n minus 1. It's that explicit formula for geometric. So if you didn't know what the first term was, you could actually put 1, right, in for n. And 1 minus 1 is 0. A half to the 0 power is 1, and then 1 times 1 is 1. So the first term is 1. Oh, by the way, I'm going off this formula here. The first term, 1 minus the common ratio. So S equals first term, 1, common ratio is negative a half. And through the magic of calculations, you would get 1 over 3 halves, and then you would invert and multiply, so you should get 2/3. All right, the next one's the same thing. The first term, it's sitting right there for free. It is 120, and then if you ratio all these out, you get the common ratio is 0.8. So how do I get that? Well, I did like 76.8 divided by 96, and that's the same thing as 96 divided by 120. It's 80%. So again, you type this in yield calculator and you get an answer of 600. And the last problem, you're supposed to do what now? Oh, you're supposed to figure out this answer. Okay, this is finite and there's 15 terms. Now you don't want to really write all 15 terms of these out because it's going to be a really big numbers. So we have Sn is equal to first term 1 minus the common ratio to the nth power over 1 minus r. And that's the formula. So here we go. First term, it's sitting right there for free. It's 4. And we have 1 minus the common ratio. What's happening every time? Well, it's multiplying by 3. And then hold on just a second. And you got the 15th power here. So that's the n. And then over 1 minus the common ratio of 3. Now, real carefully, you type that into the calculator, and you get a really large number. So you definitely want a calculator for this. 28,697,812. Yay! And we're done with the practice test. I hope you enjoyed this explanation. Good luck on the test tomorrow.